Okay, so we're going to start off with some middle school math and some algebra to tie in so that you can see what you've been doing in trig is not all that different. Okay, so who would like to tackle this first one? X squared minus 25. Yes, ma'am. Okay, you factored it, and what did you get? Excellent. X minus 5, X plus 5. Don't worry about the B. We're going to do part B in a moment, okay? All right, who would like to tackle number 2? All right. And why 2x? Okay, it's got a GCF. They both are divisible by 2x, right? And that gives me x plus 4. Excellent job. Okay, who can talk to me about number 3? Yes, ma'am. Uh-huh. Okay, but it's an addition, not division. It's hard. I know it's hard to see the symbol back there. Yes. If it was division, yes, we'd multiply by the reciprocal. Okay, go ahead. Excellent. So I need a common denominator. So you can do it where you rewrite each fraction, which is probably how you learned it in elementary or middle school. But the shortcut is take this one up and multiply, take this one and up and multiply the bottoms together. That's the shortcut. So 3 times 1 is 3. 2 times 1 is 2. So 3 plus 2 over 2 times 3, which is 6, which gives us 5, 6. You could have also said, oh, my common denominator is 6. How do I get it? Multiply by 3, multiply by 3, multiply by 2, multiply by 2. That's how you would have learned it in elementary school, okay? Everyone good? All right, so this is the same problem, just an algebra version, right? So who wants to tackle this one? Yes, sir. Okay, this is missing x plus 5. And the other one's missing x minus 5. And the bottom's going to be? I'm going to multiply those two together. X squared minus 25. And we're going to talk about a shortcut. All right, look at the numerator. What do you notice about the numerator? What cancels? The 5 and the minus 5. So my final answer is 2x over x squared minus 25. Excellent. Okay, we're going to look at these problems now through the lens of trig. Okay, so all that's different is, like a cosine might show up. But it's the same problem, okay? So here we go. This is the problem that you did, and here is B. They are the same exact. This is the difference of perfect squares. So what's the square root of this? Yep. Cosine x. Put one here, put one here. I have a plus 1 and I have a minus 1. Done. I have a plus 5, I have a minus 5. All that's different is the word cosine. Okay? All right. So, is this a perfect square? Cosine to the 6th power. Yes. Whenever the power is even, it is perfect. So what is the square root of cosine to the 6th? To the 3rd. So this would be cosine 3x plus 1, cosine 3 cubed, x minus 1. Yay? When I have a power and I want to take the square root, I divide by the root, which is 2. If I want cubic, I divide by 3. Yes? Okay. Thanks. Okay. Yes. Okay, let me pause for a second. Okay, so now let's look at the second problem I gave you. And we were told that they had a GCF of 2x, and then it became x plus 4. Oh. Okay, so what is the GCF? What's the GCF? Cosine x. Okay, so When I take a cosine x away from this, that leaves me with cosine squared x minus 1. Time out. Red flag. Why should a red flag go up? Because there's a squared and there's a 1. Red flag. I should take out my half sheet of trig identities. No, close. Shh. Shh. Okay, time out. Shh. No, listen, please. Sine squared is the same as cosine squared minus 1. This is, no, it's not. Sorry. I wrote it wrong. 1 minus cosine squared x. Yes? That is from your identities. This, okay, first of all, I heard a bunch of different things called out. You need to remember, inverses, reciprocals, reflections, those are all different things. The inverse of sine is sine to the negative 1. The reciprocal of sine is cosecant, okay? The reflection of sine is negative sine. So when I look at 1 minus cosine squared x, this is the opposite. Therefore, it is reflected. So if I make this negative, that positive, this now matches this. So that gives me cosine x times negative sine squared x. Okay, a negative times a positive is a negative. So negative cosine x sine squared x would be my final answer. Okay? Better? Okay, let me pause it. All right, so problem number 3, we got the common denominator and we got 3 plus 2 over 6 was equal to 5 over 6. So what am I going to do for this one? Find the common denominator. The fastest way is to multiply up, multiply together. So 1 times sine x is sine x. Cosine times 1 is cosine x over cosine x times sine x. Now, in this case, that was a waste of time. I picked a bad example, all right? Because tell me, what is 1 over cosine? It is secant. What is 1 over sine? So this is technically, and I could simplify this and still get this. This is technically secant x plus cosecant x, which I believe was on your paper yesterday. I can break this down and get that. Okay, so we're going to practice breaking down. My point of doing this problem was to give you practice doing this. That's fine. That's where we're going today, okay? All right. Shh. Let's look at this one. It was x plus 5 plus x minus 5, x squared minus 25. So it became cancel, 2x over x squared minus 25. Okay, let's look at one that involves trig. Okay, so I need a common denominator. Somebody walk me through. I like the way you said that. Cosine x, this one is missing cosine x minus 1. And the other cosine x is missing cosine x plus 1. And when I combine my denominators, I'm going to multiply. So cosine x plus 1, cosine x minus 1. All right. Okay. Yes, so now I'm going to do what? Use the vocabulary and you can do it. What's the vocabulary? What's the vocabulary? Distribute. Now you can take over the problem. I want to hear the vocabulary. Okay, give me a second to move the screen because I can't hit the down arrow. Oh, I messed it up. Okay, there we go. All right. Which is cosine squared. Uh-huh. It's cosine x, yep. And then negative cosine times cosine. Negative cosine squared x and negative cosine times 1. Cosine x. Great. Now, a shortcut. How many of you, show of hands, learned FOIL in algebra? Okay, you either learn FOIL or double distribute, right? Now, somebody should have been nice to you and told you if they match, if everything matches but the sign, you only need to do Florida. O and I cancel each other because of the plus and the minus. Only if everything matches. So you just need to find Florida, first and last. Only if, see how this matches and this matches, but the signs don't? Okay? So cosine times cosine. And 1 times 1. And they're different signs, so negative. Okay, shortcut, shortcut. All right, so now look at the numerator. What do you notice? This cancels this. Do these cancel? No. What's negative 1 plus negative 1? All right, so I have a negative 2 cosine x over. What do you know about cosine squared x minus 1? We saw that a couple minutes ago. It is negative sine squared x. Yes? 1 minus cosine, look, 1 minus cosine squared is sine squared. I went backwards. I did the reflection. So it's negative sine squared. What happens to negative divided by negative? It cancels. That's my answer. Okay. Good? All right. So I'm going to pause for a moment. Okay, so we're going to look at problem number 3 from yesterday's worksheet. Now, there are 2 rules I told you. 2 rules that I told you. The first rule is look for those squares and look for 1s. Does this have a squared or a 1? No, that means it's not one of the trig identities. The next thing I said to make the problem easier is rewrite everything in basic trig, meaning either sine, cosine, or tangent. And typically, it's only sine and cosine. Okay? So that's what we're going to do. We're going to rewrite this using sine and cosine. So this one's already in sine, so I'm just going to bring it down. Can someone rewrite cotangent x using sines and cosines? Yes, sir. Cosine x over sine x. Oh, now does anyone see something? Not cross multiply, cross cancel. Boom, boom. What am I left with? Problem done. Okay? It all comes back to some of the key skills you learned were in elementary school. How fractions work and stuff like that. Those are very essential to what we're doing, okay? And I know you haven't worked with those skills in a long time, so we gotta find that in that file cabinet in our brain and bring it to the forefront. Okay, number 4. Okay, red flag should be going off. Oh, I see a 1, but this is not a cosine squared, yeah? I see a sine squared. I would like both of these to be in the same term. I'd like them to be in the same term. So, is there some way I can rewrite sine squared? Yes, ma'am. Oh, excellent. 1 minus cosine squared x, and then we have 1 plus cosine x. Can I break either of these down? Which one can I break down? The top, because it's a perfect minus a perfect. It's the difference of perfect squares. So what's the square root of 1? So I get a 1 here and I get a 1 here. The square root of cosine squared, cosine x, and a cosine x. And it's different, so I need different signs, a plus and a minus. I kept my denominator. Now what do you notice? Cancel, cancel. So my final answer is 1 minus cosine x. Okay? So I want you to either check your work, redo it, or try it if you did it from yesterday. Okay? Number 7. Look at number 7 and try now. Okay, so talk to me. What do you want to exchange out? No, you've been giving me too much today. I'm proud of you, but I need somebody else to step up their game. Whoa. Oh, yes, I want to rewrite cosine squared x, yes. Okay? What do you want me to switch it out for? 1 minus sine squared x, okay? All right, somebody else take over. Yep. 1 plus sine x. And that's because it is the difference of perfect squares. Okay, somebody else take over now. Somebody, yes. Mario. Excellent, I can cancel it out because they match, and what am I left with? 1 minus sine x, great. Okay. You can put that paper aside. We're now going to add a new piece to the puzzle. Okay, so I wanted to know, what did you notice with this one? And I heard, oh, it has theta. On your paper, it has theta. Theta is just a Greek variable, okay? So you can use theta or x. I typically, if I'm copying it out of a textbook, will use x because I'm not very good at drawing theta. Okay, so what else do you notice? What do you notice that's different from the problems we've been doing? It has an equal sign. Okay, so here's the rule. Which side is the simplest? The most simple, sorry. This side. So that is a do not touch. A do not touch. So we're going to cover that up and pretend it does not exist. So this is now like what we've been doing, okay? So we're going to simplify this side. Do I see a squared and a 1? No. So it's not one of my identities. So that means I want to rewrite everything using sines or cosines. So am I going to keep or change? What would you like me to write it as? Helps if I'm on the pen, sorry. 1 over sine x times sine x. Keep or change? Keep. Okay. What happens when if I did 1/2 times 2, what happens? This is going to cancel this, and I'm left with 1. Oh, does this look familiar? 1 and a perfect square. What is it? It is cosine squared. Can I go any further? No. Well, let's take a time out. Oh, it matches. It matches. Check. Done. Finito. Yes. Okay, so when we prove, you cannot move anything over the equal sign. No. When you prove, you have to simplify one side. Okay? Good? All right. Oh, did I forget to? I forgot to type that one. Sorry. Okay, so we're going to do number 2. Number 2 says, so sine x parenthesis cotangent x plus tangent x equals secant x. All right. What would you like me to do? Oh, change. Sine x cosine over sine and sine over cosine. And I'm not going to touch that side. Now, I'm going to, what's the key word? Distribute. When I distribute this sign to just this fraction, what happens? It cancels this, leaving me with cosine x. Okay. All right, so does anything cancel when I multiply here? No. So that's going to become sine what? Squared x over cosine x. Sine squared x. We sign the trig, we powered the trig, leave the variable. Okay. Now, I'm going to put this over 1 because I have a fraction and I want to combine, so I need them both to be fractions. What would you like me to do now? Okay, get the same denominator. All right, so cosine times cosine, cosine squared x, 1 times sine, sine squared x, and 1 times cosine, cosine x. Ooh, red flag, red flag. What's the red flag? The top equals 1. Okay, so this looks pretty good to me, but when I look at the other side, it said secant. Ooh, can I change this? 1 over cosine is the same as secant. So secant equals secant. No, no, no. In proving, your final step has to match the other side. Okay? Yes. Where's your magical half paper? It makes it easier if you have your trig identities out, especially since we're just learning them. The more and more problems you do, you'll start recognizing these. Okay, next problem, final problem for today, says, now this one's a little bit different. Okay, so, normally I would say put everything in cosine and sine. But does anyone notice something? Yeah. It's a plus and a minus. It's the Florida foil. So, look, watch with me. They match except for the sign. So, we don't need foil, we just need Florida. Okay, so F in Florida becomes cosecant squared x, and L is cotangent squared, and they're different signs, so I minus K. Hello? Does that look familiar? It's one of the identities. What does it equal? 1 equals 1, problem done. Good? Better? All right, we're going to stop there for today.